Okay, these are the examples for Geometry A, Credit 1, Lesson 1.4. And our first example up here is for problem number 1. And problem number 1 says, find the value of angle B if the pair of angles are complementary. And so this is a new vocabulary word, but kind of a similar concept. We've kind of, in a previous lesson, kind of dealt with right angles, but let's talk about that in the context of the word complementary. So complementary is referring to two angles whose sum is 90 degrees. And so the sum of two complementary angles is 90 degrees. And so they want us to find B here. And so even without telling us the angles were complementary, we knew that they added up to 90 degrees. But again, we're just introducing that vocabulary word so that we are aware of that as well. All right, so we have one angle is going to be called B. The other angle is 52. So B plus 52 equals the total of that entire big angle, which it's a right angle, or we're told that they're complementary. Either way, the total is 90 degrees. And then just one step to solve. We have a positive 52. The opposite of adding 52 is to subtract 52. The 52s cancel out, and we have 90 minus 52, which gives us 38. And so B is 38 degrees. That would be the measure of angle B. All right, so now onward to our next example for problem number 2. And so for problem number 2, it says find the value of B given the pair of angles are supplementary. Well, we just learned what complementary means, that those are two angles that add up to 90 degrees, and supplementary means the two angles add up to 180 degrees. So we're going to set up our equation in a similar way that we did for number 1, except that when we add the two angles, B and 42 together, we're not going to set it equal to 90, but since these angles form they're supplementary, which means they form a straight angle, we're going to set it equal to 180 degrees. And so to solve for B, very similar to what we did over there, we have a positive 42, so we're going to subtract 42 to both sides. And we have B equals 180 minus 42, and we subtract that, and we get 138 degrees. And so here, B is 138 degrees. All right, so those are the examples for problems 1 and 2. Now let's move on to an example for problem number 3. All right, so for problem number 3, it says segment RU. So let's go ahead and draw that up here. And let's draw the figure up here. So it says segment RU is an angle bisector. So the fact that RU is a bisector. Now it says segment there, but really this is a ray, isn't it? Because we have an endpoint and then going on forever in the other direction. So that would be a ray, because that does appear to be an arrow there in the packet. At any rate, that is a bisector. And let's label it as such so we don't forget that. And then over here we have, this is Q and this is S. And so we're told that QRU is 70 degrees. Well, in our example, we're going to use 80 degrees. So here's QRU, and that's going to be 80 degrees. Now remember, this is a bisector, so that means this angle and this angle are the same measure. That may come in helpful in a second here. What they want us to do is to find the measure of the big angle QRS. So here's QRS is the big angle here, and that's what they want us to find. So let's talk about how we do that. So the measure of angle QRS would be equal to the sum of these two angles here. So if we call this X, this is what we're trying to find here. Now you say, well, we don't know the measure of this angle, but think about it, we do. Because if this is a bisector and this angle are congruent, if this is 80, then this also has to be 80 degrees. And so what we're trying to find here, angle QRS, which is our big angle here, that's going to be equal to this angle here, QRU, which was 80 degrees, plus this angle here, SRU, which is also 80 degrees, because once again, we knew that because this is a bisector, so those are equal. So now X is actually already isolated here, so there's nothing to do to isolate X. The only thing that we have to do is to simplify what's here on the right-hand side. We just add up 80 and 80, and we find out that X is 160 degrees. So that is our example for problem number 3 there on page 51. So now turning to the next page and taking a look at an example for problem number 4. Let's go ahead and do that. All right, so for problem number 4, it says solve for X given the two figures form a linear pair. So wait a second. So we've learned that angles are, we talked about supplementary, and that looks a lot like supplementary, you might say, and it is related to that, but we're going to talk about how a linear pair is slightly different. So in the packet, we'll name it with the same letters. Or maybe, well, you know what? Let's do this. Let's use something a little different, right? That doesn't hurt, right? Okay, so let's go ahead and set this up. Now, in our example, this is going to be 11x plus 4, and this is going to be x plus 20. And so we're told that these two angles form a linear pair. You say, well, aren't they supplementary, because isn't this angle and this angle together forming a straight angle, 180 degrees? And you're right, they are together forming a straight angle. It also can be called a linear pair because, yes, the sum of the angles is 180, and they also share a common side. So when they share, we have two angles that are supplementary, and they share a common side. So notice angle ABD and angle DBC, they both share this side here. When the two supplementary angles share a common side, we can also call that a linear pair. So there's just one more term to add to your vocabulary there. So we set this up as you might think. And another thing you can do is pause the video and say, okay, let me see, think this through and see if I know how to set this up before going on. So a good idea might be to pause the video now and see if you can do that. All right, so now let's go. And if you pause the video, here we go. Here's what we're going to do. So these angles are supplementary. They're a linear pair. So 11x plus 4 plus the other angle, x plus 20, equals 180 degrees. So again, so our angle here, 11x plus 4, plus the other angle, x plus 20, so those are two angles, equals 180 degrees, because together they're supplementary, they form a straight angle, and they're also a linear pair, which all those things mean they add up to 180 degrees. All right, so to solve this, just 3 steps to solve. Our first step is going to be to combine our like terms. 11x, so that's our x terms. We're going to add up our x's. 11x plus x is 12x, because remember, when there's no coefficient here, we know there's a 1. So 11 plus 1 is 12, so 12x. Now, also with like terms are constant terms, the 4 and the 20. We add those up, and we get 24. So numbers that are by themselves, constant terms, are also like terms. And of course, we bring down the 180. Our second step here, remember when we're solving an equation, we always deal with our addition and subtraction before the multiplication. So we have a plus 24. So the opposite is to subtract 24 to both sides. The 24s cancel, and 180 minus 24 will give us 156. Our final step, x is being multiplied by 12. So we divide by 12 to both sides. The 12s cancel, and 156 divided by 12 turns out to be exactly 13. So our answer, x, is 13. Now, all they're asking us to do here is to solve for x, but if they would have asked us for the measure of either one of these angles, we could quickly substitute that in and determine the measure of either angle. that might even be a good idea to do, because then you could do that, and if those two answers add up to 180, then you know that you did everything right. But as it is, they only ask us to solve for x. All right, so now that is our example for number 4. And now let's take a look at an example for our last problem in this lesson, problem number 5. So here we go, an example for problem number 5. So let's go ahead and draw our diagram up here, and we'll even draw it in the packet. It's at a little bit of an angle like this. So we'll do that too, just so it looks the same. And let's set all this up here before we read it. And we'll call it, this one we'll use the same letters. We'll do that. How about that? Okay, so here we go. So it says segment RT. RT is the big segment. It says it's equal to 40. In our example, we're going to use 80. And RS is 15. We're going to use 20 here in the example. And then the expression that represents the other part of the segment, it says ST is 5x, but we're going to use 3x. So that's how you'll label everything, and I believe it's labeled also in your packet. And they want us to find the value of x. So remember back from the first lesson, something called the segment addition postulate. In fact, let's write that up here. Segment addition postulate. And that said that if we have a larger segment and it's cut into two pieces, whether the pieces are equal or not, this one piece plus the other piece equals the original larger segment. And so that's how we're going to set up our equation here. So one of the smaller pieces, 20, plus the other smaller piece, so RS is 20, ST is the 3x. So the two smaller pieces added together equals the entire segment, which has a measure of 80. And so that's how we set up our equation. 20 plus 3x equals 80. So now we're going to solve this here, just 2 steps to solve. Again, we deal with our addition and subtraction first. We have a positive 20, so we're going to subtract 20 to both sides. The 20s cancel, and we bring down the 3x. 80 minus 20, we subtract or simplify that, we get 60. And for our final step, x is being multiplied by 3, so we divide 3 to both sides. The 3's cancel. And 60 divided by 3 is 20. So for our example, x is 20, and of course number 5 would be done with in the same manner. All right, that's it for the examples for lesson 1.4, the last lesson of credit 1. And so good luck with the problems and do your best. Remember, pause, rewind as needed. And that is it. So we'll see you in the next video. Bye and God bless.